My name is Patrick Moorhead. I'm founder, president, and principal analyst at More Insights and Strategy. And to my right and to your left is...
Anshul Sog. I'm staff technologist and technical writer at More Insights and Strategies.
So, thanks for coming. What we're going to talk about today and what we're going to show you is what I consider somewhat of a disturbing trend in the mobile industry. And that's this whole concept that a phone with 8 cores is actually better than a phone with 6 cores or 4 cores. And what we're going to do is run through some usage models and also some benchmarks, and we're going to see if that's true or not. We're going to run 3 benchmarks, 2 tools, and of course, because I've heard this is the most important thing, 38 cores. We're going to be publishing a paper after this documenting all the gory details of everything that we've shown here. So I already told you about the megahertz myth, and I'm really passionate about that. I've been doing benchmarks and round benchmarks for 25 years in servers and PCs and now mobile. And I think the challenge might be that some consumers might be buying these but maybe making the wrong decision in buying a phone that has more cores than the other. And in actuality, all cores are not the same. There's bigger cores, there's smaller cores, there are really big cores. In fact, the world's largest or best-selling smartphone has two really large cores. And if you're not into all this technical mumbo jumbo, I like to use analogies. And my favorite analogies is like a lawnmower. Like you wouldn't buy your lawnmower. You wouldn't choose lawnmowers between one that has 8 cylinders and one that has 2 cylinders. That would be completely ridiculous. And Anshul, I know you have a favorite analogy as well. It's a car analogy.
Yeah, actually, it's essentially an analogy between the Toyota Yaris and the Audi TTS. Both of them are actually 4-cylinder engines, but the difference is that the 0 to 60 of the Audi TTS is vastly shorter, and it also has a much higher top speed, and it has more torque, more horsepower, and in the end, the gas mileage or the range that the vehicles have is not that big of a difference, and even though you have essentially the same amount of cylinders. Right.
Oh, so I shouldn't expect that the Yaris is a better performer or the same performer as the Audi TTS.
No. Okay. I mean, essentially, cylinders. Not all cylinders are the same, just like not all cores are the same. There are lots of different analogies you can look for in this kind of situation, but the truth is that no 2 cores are the same.
Anshul, if you can kind of give the rogues gallery here of these awesome phones, I'd appreciate that, and maybe talk about some of the specifications as well.
Absolutely. So on the left here, we have the LG G4. This is a fairly recently new phone. This one has 6 cores. It's a Snapdragon 808. Then here we've got the HTC Desire 820. This one's got an 8-core chip from MediaTek. This one's the Xiaomi Mi 4i. This one has also 8 cores, and these are on a Snapdragon.
Yeah, so this is a top seller. This is the top-selling brand in China, basically.
Yes, but this actually launched in India first.
Okay.
So it's both India and China at this point. And then that one's an 8-core that has 8 A53s.
Okay.
Then this one is the Samsung Galaxy S6, which everyone pretty much knows. This one's got 4 A57s and 4 A53s, and that's a big little configuration. And then this is the LG GFlex 2, and this one has 8 cores also, but this one is 4 A57s and 4 A53s. And that's a Snapdragon also. The only phone on here that doesn't have 8 cores is actually this one right here. This one has 6.
Okay.
Has 2 A57s and 4 A53s.
Okay. So let me ask this. Have you modified the hardware at all inside of these phones?
Not whatsoever.
Okay. How about the software?
So in order to get some of these devices to disable the cores as we need them to show you guys the difference between 8 cores, 6 cores, 4 cores, 2 cores, we actually had to root the devices. So all of these devices are rooted, and they all come with the stock kernels. We were going to try and flash them, but we didn't want to mess with any of the schedulers that might be in there or any kind of optimizations the manufacturers have made on their SoCs.
Okay.
So we're pretty much running almost stock. Admittedly,
Yeah.
we're rooted, but I mean, that's pretty much what we had to do to get to these.
So as I talked about, some of us have been doing benchmarking for a long time. Again, the longer that you've benchmarked doesn't make you a pro, but it certainly lets you understand the tricks of the trade and some what the pitfalls are. And there's two tips in particular. One of which I think we've talked about. But the other one is it's really important to not rely on a single benchmark. And no matter how good a benchmark is, you should never just rely on one. And that's a mistake that I feel like some people are doing out there. Videos all over the internet talking about this. The other one, which I mentioned before, is shipping devices. Make sure the devices are out of the package. Aren't modified in any way. And it's interesting, I hear conversations out of the internet that says, oh, this phone tested differently when I bought it from a carrier than it did when you did the initial. So be really careful about that. And Anshul, what I want to ask you about is, and I've written a few articles about this, and I know you have, what makes a good benchmark?
Well, a good benchmark, really, the point of a benchmark and a good benchmark in that sense is you want it to try to replicate real-world applications as much as possible. So you want that application or that benchmark to mimic or actually be an application. And at the same time, you also want the people who are making the benchmark to be as transparent as possible in their production of the benchmark, how it gets utilized by different manufacturers and reviewers. And yeah, so those are the two main points. In addition to that, the benchmark needs to be consistent because there are some benchmarks out there that might actually give you a result, but if you test it, if you test that benchmark 1 time, 2 times, 3 times, you don't get a consistent result. And for a benchmark to be a good benchmark, it needs to give you a consistent result within about an error range of about 1 or 2%. So really, you should only have a very slight variation in benchmarks. And if the benchmark varies wildly, then either you have a problem with the device or you have a problem with the benchmark. And then on top of that, it also helps to have that the benchmark manufacturer or the company that writes the code for the benchmark has the ability to moderate cheating. So in the past, some smartphone manufacturers actually participated actively in cheating in benchmarks, optimizing their SoC's performance to boost itself for when it detected a certain benchmark. So some actual benchmark companies went out and banned certain devices or completely removed those devices from their benchmark lists because they were cheating. So the 3 main benchmarks we're testing are PCMark, Basemark X, and Camspeed. PCMark is designed to be a true full system benchmark, test the whole phone in a lot of different ways. Basemark X is designed to test the game performance of the phone, specifically utilizing Unity Engine, which is the same engine that most game developers use when they make games for phones. And then the last one's Camspeed, which is it's a camera benchmark, and it's basically designed to benchmark the phone's ability to focus, take pictures, do flash, and essentially benchmark the camera performance of the phone. And basically, we're taking these 3 and combining them together to create a very kind of wholesome view of how a device would perform. And combining them together, we can get a good idea of what kind of performance you'd expect in the daily use of the phone.
That's good. In addition to the benchmarks, we're also going to be showing YouTube and WeChat. Pretty much everybody around the world knows at least YouTube. WeChat is pretty much the biggest app out there, particularly in China, for a social media app. So also, what are the tools that you're using here, so everybody knows?
So the primary tools we'll be using are 3C CPU, which is actually a very broad suite of tools, but there's the CPU tool itself allows us to actually go in and disable certain types of cores, and basically go in, and after the phone's been rooted, then 3C allows us to turn off cores and do our thing. And then on top of that, we're also using Qualcomm's Trepin Profiler, which is actually a monitoring app that allows you to monitor a lot of things on the phone. But for what we're using it for, we're actually monitoring the frequency and the load of the CPU cores when we're doing certain tasks, and also to show, which cores are being lit up, which ones aren't, and how often they're being lit up. And you can actually see, we'll have visualizations so you can see what it looks like when we're doing that. All right, so let's boot up Basemark and take a look here. All right, so we'll get the G4 going, and then get some of the other devices going. So Basemark there. I open the browser instead of Basemark.
I'm reading your mails.
Thanks.
Do you mind?
Yeah, well, unfortunately, I'm a bit fat-thumbed, so here we have Basemark, and got that loaded. Let's go back to this. Still had it open on this one. All right, so Basemark.
Yeah, so make all of them run here.
Let's clear that out. All right, so they're all ready to go. And the work benchmark is the only benchmark that they have. So we're just gonna run them all together. They also have a battery benchmark, but that doesn't actually test.
Yeah.
It just winds down your battery, so you can get an idea of what kind of battery life you
So
get.
why don't you talk through the tests as they're coming in here?
Sure. So the different tests that we have here are, the first one that we see is web browsing. And actually the web browsing benchmark actually uses real touch inputs that they've programmed into the benchmark to do different kinds of scrolling and pinching and zooming and all the kinds of things you would normally do when you use a web browser. And they do other things, everything you would normally find in a normal type of browsing situation. They created their own Pinterest style kind of web page here, just to give you a more realistic experience. And it measures different things like time to search, time to load images, time to close images. And then it kind of just moves along after the web browsing benchmark into some image editing stuff. But this is actually image editing inside of a browser still.
Okay.
So
the one thing that I do like about this benchmark is that it's very well documented in terms of what they're doing. And again, the company, if they find somebody is cheating on the benchmark, they will actually tell them they're cheating and remove their results from their websites, because there's a lot of people, and this has been very well documented on some technical websites, that people have gamed it. So, and that's an issue.
So this is the next test. This is a video benchmark. There's 4 different videos, and they're all pretty much of a polar bear. And we'd love to show you the benchmark in landscape like this. And actually we have some ability to do that over stream, but it will affect the performance of the devices. So we'll only be able to show you the final results once they're done. So we want to make sure that we don't affect any of the performance of any of the devices while they're testing.
Yeah. So Anshul, are these some fancy codec or some non-standard codec?
No, it's just H.264 video.
Okay.
Yeah, and basically it's just different video shots, and kind of, it even, it tests every single type of thing you could think of when it comes to using a video. And now you can see it's switching to the next test, which is writing. And here it actually, measures things like time to copy text, time to paste text. You know, it actually uses real commands to do this. And you'll actually watch as it goes along on some of the phones, especially the two LGs. It'll even copy things to clipboard and they'll pop up because it actually pulls into the UI that LG has on there, which it shows you the clipboard whenever it copies anything.
Yeah. Yeah, and while technically all of these benchmarks are synthetic in its technical nature, what it is doing is it is representative of real applications, at least where it is today. Now, these benchmarks need to be updated every year or whenever there's some major transition, but that's really important that that I bring that out.
Yeah, and this company, FutureMark, works very closely with most of the smartphone manufacturers and SoC vendors and gives them access to these benchmarks well in advance of its release so that they can make any adjustments or complaints or comments about them well in advance of the benchmark actually being released. So it's actually a very, very widely accepted benchmark across the industry. It just takes some time to run, but it's very, very consistent and it's very encompassing in terms of what it does. As you'll notice, it doesn't actually, none of the tests actually test gaming, which is why we're doing the next test, which will be Basemark X.
Yeah, I actually think the name of the benchmark, which is PCMark Work, is a little bit of a misnomer.
You're doing photo, so the next one is photo editing, and here it's basically taking different photos, it's changing exposures, it's doing different types of effects, things that you would normally do on a smartphone on a regular day basis, and it even does them in a pretty high resolution just to make sure that it's, you know, up to par. Some of these phones are not as quick as others, so they're going to move along more quickly than others, so that's why one is still not quite on, or two of them are still not quite on the photo editing benchmark.
So Anshul, what are, these two seem to be falling behind a little bit. What is there a characteristics that these two phones are similar in a way?
Yes, actually they are. Both of these phones utilize 8 A53 cores, which are the low power cores that ARM has, and those are generally utilized in big little configurations with larger, more powerful cores to switch between the back and forth to get a better performance power curve.
Yeah, so I actually think this is a great example that shows that this clearly shows that all cores are not the same here.
Yeah, so we've already got some scores here. So the 6-core LG GFlex, actually no, this is the 8-core GFlex 2. This has 8 cores and that got a 4577. Then the 8-core Samsung Galaxy S6 got a 5241, which is quite a bit higher. And then we have the 6-core LG G4, and the performance of this is actually higher than it is on the 8-core. So some people might not realize that a 6-core phone is actually faster than an 8-core phone. And they're both Snapdragons, they're both Qualcomm's chips, so there really shouldn't be much of a reason other than the fact that the core count isn't really a factor.
Yeah, I think not only is it true for core counts, but it's also the whole concept of heterogeneous computing, where the reality is that most modern smartphone workloads, through a diversity of workloads, take advantage of not just the CPU, but the GPU, DSP, obviously the modem, memory controller, and you have to have a good balance of those. And you also, handset makers and particular SoC makers need to find the best combination to put those together, because there is magic in putting the glue that pulls these together. And there's no other better way to characterize it other than heterogeneous computing.
Yes, and the thing is that this 8-core Xiaomi Mi 4i got a score of 3436, which is not as high as 5,000 or 4,500, but that tells you that once this finishes, we'll go over all of the different benchmarks and show you the different performance curves. But really, I mean, we're already ranging from 3,500 to 5,200 in terms of performance when we're really looking at about 8 cores for most of the phones.
Right. This is actually a perfect example. Same core count, drastically different performance numbers.
Yeah, I mean, these are both 8-core phones. And other than that, it's a pretty easy thing to see. PC Mark, as you can see here, this is the score, 4580. I'll put it in landscape just to make it a little bit easier for the YouTube viewers. Essentially, what it comes down to is it shows you all the different clock speeds, temperatures, and battery charge. As you can tell, we charged all these phones to 100% before we started this test, or all the tests. And here it shows the full work performance score, and then the sub-scores for all the different tests. And all those sub-scores combined together in aggregate become the work performance score, and that's how it's generated. So a combination of 4 different benchmarks with multiple tests are then aggregated together to create one score.
Yeah, and hopefully it's evident why at this point we do like this benchmark.
And now you can see all the scores side by side. And here we have something from 1600 all the way up to 5200. So this phone, the Samsung Galaxy S6, has the same amount of cores as the HTC Desire 20, but it has more than triple the performance.
Yeah. Again, this benchmark uses the Unity game engine, which is not the game engine for games like Candy Crush. It's a game engine for first-person shooters and things that have very rich graphics. It's also Unity's cross-platform, which, regardless of which, whoever you want, iOS or Android, it'll work there too. So let's get these started here. And the other thing is we're running these on high. Okay, that's one very key point. And the other thing is we are running these on screen. Okay, and you may say, wait a second, off screen is a much better way to do this. Well, remember, we want to test the phones, not the components here.
Yep.
Okay, so if you have a higher resolution phone, it will be doing more work.
And possibly a lower frame rate.
Yeah, and we know that, but that is exactly the way that the consumer is going to be playing their games. They're not going to say, hey, wait a second, I'm going to run this off screen, okay, and go somewhere else. Most people aren't going to do that. There will be a few who will, but we want to be very clear on why we're testing like that.
Exactly. And thanks for explaining that while I did this. Here we go. So we're going to start all the tests. And so this benchmark actually comprises of 2 different scenes that it kind of goes across and takes shots of. And the first one is this kind of dunes style benchmark. It's a dune style scene in some space stuff. I don't even know. But the next one is going to be a hangar, like a military hangar. But if you actually look at the displays, you can see it's a very high quality benchmark. It looks marvelous on any screen.
Are you sure this isn't Candy Crush?
Yeah, it's
okay.
Pretty far from Candy Crush.
Just wanted to check.
It's probably not as addicting as Candy Crush, but it's pretty far from it. And the other thing is that these benchmarks are the pinnacle of what you can see in a mobile game today. So this is almost a worst case scenario.
Okay.
But the other thing is, the reason why we picked a really high quality test is so that it doesn't go too high of a frame rate, so it doesn't go beyond the refresh rate of the display, because otherwise then you have to use an off-screen test.
Okay. Now, where might an off-screen test be helpful, Anshul?
An off-screen test would be helpful in a situation where you want to compare different GPU architectures, or if you want to compare, like-for-like systems with the same GPU, right? You're not really looking at, the whole system. You're looking at a component of the system and mostly focusing on the GPU.
Yeah, and my mind always goes to, well, what if you plugged it into a 4K monitor? Well, that is true. You would be able to do that, but with most TVs at 1080p, doesn't necessarily hold water. So it's not that we think off-screen's bad. It does a good job talking about the components, but again, what we're doing is we're testing phones, not chips.
Exactly. And as you can tell, the two fastest phones with the A57s and A53s with the 8-core combo and Big Little, those two finished first, which isn't much of a surprise because they do have the most big cores. And then the next one will probably be this one.
So Anshul, I have to ask, why is it 0?
So the reason why it's 0, and this did finish next, is because we didn't run off-screen and on-screen. If you run both, it gives you a full score, but each of the scores are actually on-screen. So we got 30 FPS and 26 FPS for each test respectively, which is playable. 30 is very playable.
Yes, just a quick question. Did you turn off the casting on this phone?
Yes.
Okay, good. Just
Yeah.
wanted to make sure.
And so this is the G4. And the G4, it doesn't just have fewer cores, it also has a slower GPU, which is why you're not getting as high a frame rate as you do on these two. And then here you have the HTC, and that's the one with the MediaTek chip. And then here we have the Xiaomi still running with the 8-core Snapdragon 615. So Basemark, the benchmark itself, it utilizes dynamic shadows. It has forward rendering pipeline. It has particle effects, normal maps, light maps.
So can you put that into plain English here?
Essentially, they use all the kinds of tools that you would normally find in a regular PC game almost. It's not even really like it's like a console or a PC game. Those are the kinds of features that they're able to utilize in today's smartphone SoCs.
Okay.
So it's really a great thing. Like the truth is, Unity as an engine is marvelous. It enables great things, and the SoCs and the GPUs inside those SoCs really allow for a great experience.
Awesome.
So the next benchmark we'll be running is called Camspeed, and Camspeed is a benchmark that is specifically designed for testing the camera. And what we've done is we've worked with Camspeed manufacturer, the company that makes Camspeed, Sofika, and they've basically provided us with a reviewer copy of the application to make sure that we get the best testing and most consistent testing of the application. On top of that, there is one snag in terms of this test that we already knew in advance. Unfortunately, there is a bug with Camspeed on the Samsung Galaxy S6, so we won't be testing this phone, unfortunately, even though it has one of the best cameras out there. They're working on it, and they told me they'll send me a copy when they can, but unfortunately not enough time. So we're pretty much stuck there. As you can see here, the performance is a little bit better. It's 16 FPS.
About 10% better, I think.
Yeah, I think it's a little bit better, so it definitely affected it. And yeah, it's unfortunate that, casting does take away some performance, but, that's, a combination of all the system.
So Anshul, let's make sure once they do get the fix on Camspeed, we report the numbers on the Samsung. We think it'll probably be pretty good numbers too.
Yeah, definitely. So Camspeed, keep in mind that this phone has 4 cores. This phone has 6 cores. This phone has 8. This phone has 8, and this phone has 8. So we're not, the performance of these phones shouldn't, be too wildly different. But at the same time, we can disable some cores and show you how the core count really doesn't actually affect camera performance that much. So we'll run these first. And this is actually a quick test, so you won't have to, listen to us ramble too much.
Okay, so tell me what it's going through right now, Anshul.
So it starts up the camera, and then it starts focusing, and now it's taking pictures, as you can hear. And essentially, it counts how long it takes to start up the camera, how long it takes to capture a photo, how long it takes to flash and capture, and then it also tests the quality of the image. As you can see, these two on the ends are actually still testing, and it's not because they're slower, it's actually because they have more camera capabilities built into the phones, because they've implemented more updated camera APIs, so they're supported. And as you can see here, these two phones already gave us scores. They actually both have the exact same score with flash. And then the Xiaomi is actually a little bit faster in terms of its overall score. But if you go over the measurements, it actually measures every component of the test in milliseconds, and that's how you can actually quantify the performance of the camera. And these two just finished, so we've got the LG GFlex 2 and then the G4, and the GFlex 2 actually got a really good score of 800, and then the score with flash was 630, so it pretty much pulled away from the rest of the pack. And then we have the G4, which is its little brother, and that one came in at 551 and 482. So it's a little bit quicker than these two other phones with flash, but about the same without.
Okay.
So the truth is, a lot of cameras and a lot of phones are very similar. The G4 is slightly set apart, but we're not really testing image quality as much as we're testing speed and ability to capture quickly, because that does affect how a user experiences the phone. So what we're also going to do is show you how something like Camspeed, which is a camera benchmark, is not affected by the amount of cores. So right now this phone is running with 8 cores. And what we're going to do is we're going to open 3C Toolbox and we're going to disable some cores. I've just turned off CPUs 7, 6, 5, and 4. And they're all the same cores, so you don't have to worry about whether or not we're turning off big or little cores. They're all the same, so we're just going down to a 4-core phone now. And basically you can go here on Camspeed and retest it. And so you saw 556 and 471. And just go back. We'll put it back here so it's the same camera test. And you'll see that really the performance of the camera is almost unaffected when you go from 8 cores to 4 cores. Even though you're running the same operating system, you're running the same applications, the phone's camera performance doesn't really change.
So Anshul, you were messing with the cores on the other benchmarks as well.
Yes.
Did you see variation in Basemark or Basemark X?
Yeah, so in Basemark, we actually were able to find, or I was actually able to find, that it did, reducing the core count from 8 to 4 did affect performance a little bit, but it was less than 10%.
Yeah, if we have time at the end, let's run through that.
Absolutely.
I think that they'd like to see that in real time.
So here you have another score, and it's 563 and 486. So or 483. It's completely and utterly unaffected by the performance of the SoC going down from 8 to 4 cores. And we can actually go down more. I think we could probably get away with 2. So now we're at 2 cores again. You can see only 2 cores are lit up. We're going to go in here and open Camspeed again and let it load and then run it.
Well, I actually think this is a good example of the power of an ISP.
Definitely.
As well. So this does take processing power, but a lot of it has been offloaded to the image signal processor. And again, this whole theme of heterogeneous computing, GPU, CPU, video decoder, all these things coming into play.
Absolutely.
The modem, the memory controller, all these things are important and not necessarily related to the number of cores that you have in the phone.
And so here we have the performance, and the performance is almost unchanged.
Right.
So, I mean, it really is showing you that even though we're disabling cores, it doesn't affect the camera's ability, because most of the camera's capability is not dependent on the CPU. However, if we were to do some HDR tests, there could be some more dependence on the CPU because of the computational capabilities that are needed there. But even then, some HDR implementations utilize GPU also.
Yeah. Now, if the Basemark test is solid and it's doing image manipulation, then it should be factored in there, correct?
Absolutely.
But to your point, I think if we had a 16 megapixel editing over and over and over, you would see a difference.
Yeah, so that pretty much wraps up the Camspeed. So the next test we're going to do is actually YouTube. So for YouTube, the reason why we picked YouTube is it's one of the most popular, benchmarks out there. Well, video applications out there. So we're going to test YouTube, and we're going to show you how they all run. Actually, I don't think we're going to show all of them running YouTube, because that would be boring. That would be boring, right? So what we'll do is we'll run YouTube on the Xiaomi, and we will have different core counts.
Yes.
So we'll show you what it looks like 8, then we'll go down to 6, we'll go down to 4, and maybe even down to 2. So we'll run the Trepin profiler. We're going to go to Profile App, and then we're going to profile YouTube. And it's going to load all the cores up.
Why don't we put that on the stand and maybe we can get a close-up of that. I know after we run this, we'll cast this.
Yes. So as you can see here, it actually shows all the different CPU cores. We've got the yellow is CPU load and the blue is CPU frequency. So right now, with just the app open doing nothing, it's actually only using 6 cores, and some of those cores are barely being utilized. Like that one down there is, peaking down, basically sitting idle most of the time. So really we're looking at like 4 or 5 cores. And part of the reason why is because they're A53s.
That's right.
And as you can tell, a lot of them are fairly low loaded, and some of them are even lower clocked, like these ones down here. So we're just trying to show you what this looks like over here in terms of utilization. And then we can go over and pull up our favorite video, which I think is, actually it's my favorite video. It's the slow-mo guys. So they do a lot of awesome stuff.
You want to put that in there so he can focus in on it?
Absolutely. I'm going to have to rotate it. And this is a commercial, so yeah, we got to skip that ad. Thanks, YouTube. There we go. So this is running in 1080p.
And again, these are 8 A53s. So pretty much
so you can,
the lowest core level of a modern phone today.
it's a bit hard to tell because of the overlays, but I can move them a little bit, and you can tell that 1080p is kind of hiding in there. So right there's 1080p. So we're running this video at 1080p, and if I rotate it, you'll get the full screen, but then the overlays will kind of get jumbled up.
Yeah.
So here you can see we're actually running fewer cores now than we were when we had the app open. So now 4 cores are completely off, just shut off entirely, and we're only using really about 3.5 cores. And yeah, it's really quite amazing that you're doing 1080p video and you're using less CPU processing power than you were before watching a video.
And also, this is, I would say, best case scenario, again, or worst case, depending on how you look at it, because those cores are very, very small, right?
Yes.
These are the little cores in a big little configuration, and there's 8 of them.
Yeah, and really, some people are questioning whether or not you really should be using 8 little cores.
Yeah.
Because that wasn't really their intention or their purpose. So yeah, there's a lot of contention in the industry about that issue. But what we'll do now is we'll actually go down to 4 cores, so you can see that you have no issues with lighting up a 1080p video.
And part of what you're seeing here is that video playback, whether it's H.264 and even in the newer phones, H.265, a lot of that is being offloaded to a fixed function piece of silicon that's inside of the GPU. Yeah, you do need the CPU to do setup and some correction, but a lot of that weight is being decoded by the decoder inside of the GPU.
Alrighty, so I've disabled some cores, disabled 4, and what we'll do is we'll go back to Treppin, and we'll profile the app again, and we'll open YouTube again, and should be able to just start the app up again. And we're already watching the video.
Okay, so let's put it back on here so we can get a tight shot in there.
Actually, I'm sorry, I disabled 6 cores. So we're actually watching 2 cores, and here you can actually see it's fully utilizing both cores. So having 2 cores in most cases is going to be not enough unless you have the right kind of application.
I think you may have killed the video.
Yeah, I think I have.
We went a little bit too low.
No,
here.
actually it was in slow-mo.
Oh, okay.
Yeah, so it's actually, they're just, looking at the video, but yeah, it's,
Okay.
yeah, it definitely does stress 2 cores quite a bit, but you can get away easily with 4, 6, 5, whatever tickles your fancy.
The final app we're going to show here is WeChat. And WeChat, super popular all around Asia. Yes, people in the US use it in Western Europe, but it is the default communication device in many parts of the country. And WeChat does have different features where you can, just like Messenger, you can send a video, you can send pictures, you can talk over it, and obviously you can text over it.
So WeChat, it's a simple chat application. You can open your chats. Here's a good friend of mine, Miriam Jawar. She's a journalist. I sent her a picture earlier. She's probably wondering why I did that, because I don't really use WeChat that much. So here you can send pictures, videos, and all those kinds of things. And this is just with 8 cores, just so you can get an idea. You can just send different images, and then it'll load them nicely and quickly. Yes, I do love my dogs. And then you can send cameras, photos. So this is a little camera app inside WeChat. And then you can also send video or walkie-talkie, so you can do a video call or a voice call. So it's a very versatile application, and it doesn't really put that much of a load on the phone, because in China there's such a broad selection of phones out there with varying SoCs that they need to be able to work on anything. So what we'll do now is we'll go and disable the cores and show you.
So how many are you going to go to? 4?
I think 4 is a good number.
Okay, so 4 of the lower performance A53s.
Yeah, and the truth is that, I think that a lot of us can agree that 4 cores in many instances is a good number. It's maybe not always the right number. Apple might think it's 2 or 3.
Right.
But it really depends on the operating system, the architecture, and what other components are in the system.
Yeah, that is a good point. I haven't even, we're not showing any Apple product here, but as we know, the best-selling phone around has 2 very large processor cores, and best-selling tablet out there has 3 very large processor cores. So that is actually a perfect example. We wanted to have consistency here among everything, which is why we're not running this or a phone even with Intel silicon inside. Okay, so yeah, why don't you press play on the video, just see what happens. People probably want to know what's going to happen.
Sure. Let me get this thing. And see, it is a little bit slow, and that may be because it's not lighting up the other 2 cores.
Anshul, what else do we need to know about WeChat? Anything else?
Not particularly. WeChat is just a really good application, I think, for a huge portion of the global population, and I think it'll only get bigger as people use it.
Okay. So let's talk about kind of what we've learned here. Okay, I think a couple things is test the full phone and not test the parts, and that's finding the right benchmark to do this. Finding multiple benchmarks. We just didn't use one. Choose benchmarks that are consistent, are reliable, that actually give some documentation on what is going on. Choose benchmarks that if they're being gamed, they're going to be booted off of the sites that actually track the leaderboards. Most important, though, I think that smartphone experience matters and performance does matter. And I think hopefully we made our case here that it's not the number of cores necessarily, it's the quality of the cores that you're putting against the experience. And as important as those CPU cores are the GPU, the DSP, the ISP, the memory controller. We didn't show the value of the modem here, but of course that is very important as well. So with that, did I miss anything, Anshul?
As far as I know, the only
before
thing
we go into Q&A.
Yeah, I think there's a few things that we're going to do after the stream was over, just for people who are interested. But really, I think you pretty much hit on most of the key takeaways. I think we have been dealing with this, too many cores thing for a long time. And there's always going to be room for more or less cores, but it's not entirely sure. It's not really entirely set in stone what that right number is, right? You and I might say it's 4. Apple might say it's 2 or 3. Some other company may say it's 5 or 6. But the truth is that if you go in and test different phones and different applications and really see what the utilizations are out there, you'll see that it's not more cores is better.
A couple of the questions that I got either on Facebook is hey, what about power? Why aren't you testing power here? So power is very, very important, we know, but that's not the point that we're trying to make here. Maybe we'll do that in the future. The best way to really find power draw, sure, you can remove the battery, but when you have full enclosures, you're pretty much ripping apart the entire phone. We're not against ripping apart phones. We've done it before, but we would like to do that after we've tested the performance and the experience. Anshul, any questions that you get or kind of being challenged on this topic?
I would say, power is a huge factor, right? Because you can't just take into consideration performance alone.
Yeah.
These are smartphones, and battery life is a factor because you're not always going to be plugged in. And I would say, there's some parallels that I've drawn from my days in the PC industry in terms of, we've encountered these issues before. I know you have. You've been in the PC industry for quite some time and had to deal with those issues. But really, I find there's very, very many similar parallels between, the laptops that we use today and the smartphones we use today. Obviously, they're not identical. The use cases are different, but the PC is a much more mature form factor in industry.
Yeah. The one thing I want to say too, another question I got, a commentary was, Pat, why are you saying 8 cores are bad and things like that? Well, I didn't initially think that 8 cores are bad, but what happened is the marketing was abused so much that it was almost like the industry couldn't handle this. More cores wasn't being positioned as a way to actually save battery life. It was being positioned as a way to connote better performance and a better experience. And I'm okay with that. So I'm not against 8 cores if they're marketed accurately and isn't done to deceive consumers throughout the chain. But unfortunately, the industry either doesn't have the discipline to be able to do that, which is one of the reasons why we're doing this today. I mean, I've myth busted a lot of benchmarks and claims that people have made over the last 25 years, and I think as industry analysts, we need to be doing things like this.
Yeah, I agree.
So guys, with that said, I want to thank you so much for tuning in. Again, we are going to be packaging this up into a paper and show you exactly what we showed you with as much detail as we possibly can. And you can also find me on Twitter at Patrick Moorhead, Anshul at Anshul Sog.
Anshul Sog, yep.
I'm a Forbes contributor, a CIO contributor. Anshul contributes to Forbes and also to PC World. You can check out our stuff there.
Yep.
So with that, I want to thank you very much for tuning in.
Thanks.